We see surveys everywhere. They're telling us who's ahead in elections, what shows we like to binge watch, you name it. But have you ever stopped to wonder how that actually works? How do you take 1,000 different opinions and forge them into one single scientific conclusion? Well, today, we're going to pull back the curtain and look at the science behind the numbers. So let's just imagine you did it. You got 1,000 people to fill out your survey. The data is in. But now what? That's the real question, isn't it? How do you scientifically go from this big pile of individual answers to a trustworthy statement about an entire population of millions? And this quote it nails it. It looks simple from the outside, but getting the answers is just the start. The real heavy lifting, the actual science, is what comes next. It's a whole process of turning what looks like a bunch of subjective opinions into something objective and analytical. And before we can even think about looking at percentages or making cool charts, we have to start at the very beginning with a crucial first step, the quality check. We have to stop and ask ourselves, is this data we spent all this time collecting actually any good? This brings us to the two fundamental concepts that are the bedrock of any good survey analysis: reliability and validity. Think of them as the gatekeepers. If your data can't get past these two, your whole project is basically dead in the water. They are absolutely non-negotiable. So let's talk about reliability first. The best analogy is a simple bathroom scale, right? If you step on it, step off, and step on again, and it gives you three totally different numbers, well, that scale isn't reliable. It's inconsistent. For a survey, if a question is kind of vague, people might interpret it differently, giving you inconsistent, unreliable answers. Now, what about validity? This is all about accuracy. So let's go back to that scale. It could be perfectly reliable. It shows you the exact same weight every single time you step on it. But if that weight is consistently 10 pounds too high, the scale isn't valid. It's not accurately measuring your true weight. In a survey, you might have a question that's super reliable, but if it's not actually measuring the concept you think you're measuring, then all your results are invalid. And here is the bottom line. This is so important. Reliability has to come first. You can't have an accurate, valid measurement if your tool is giving you inconsistent numbers that are all over the map. You need that foundation of consistency before you can even hope to be accurate. Okay, so let's say our data passed the test. It's reliable, it's valid, it's good to go. Now we can finally start exploring it. And this first part is all about just describing what we have. We're taking a snapshot to answer the simple question: who are these people who answered our survey? Let's use a simple example to make this real. Say we ran a survey asking, who's happier, coffee drinkers or tea drinkers? The very first thing we do is just describe our sample. And as you can see here, we've got a pretty even split between the two groups. So how happy is this group overall? Well, the first thing most of us would do is calculate the mean. That's just the classic mathematical average of all the happiness scores. For our group, that's a 6.8. But you gotta be careful with the mean, because a few really happy or really unhappy people can skew the whole number. And that's exactly why we also look at the median. This is the score of the person who is literally smack dab in the middle if you lined everyone up from least to most happy. A median of 7 here tells us that half the group is happier than a 7 and the other half is less happy. It gives us a much more stable picture of the group's center. And finally, there's one more number we want: the mode. This is just the most popular answer. It's the score that came up most frequently. In our case, that was an 8. So now we've got these 3 different numbers: the mean, the median, and the mode. And each one gives us a slightly different but very valuable clue about our data. Okay, we've described our 1,000 people. But now we get to the really exciting part, the magic trick of statistics. How in the world can we take what we learned from just 1,000 people and make a credible scientific claim about all coffee and tea drinkers out there? Millions of them. The key is something called sampling error. Now, don't let the word error throw you off. It doesn't mean we made a mistake. It's just the natural, unavoidable uncertainty that you get because you talk to a sample instead of everybody. And that's literally why inferential statistics was invented, to give us the tools to measure and manage that uncertainty.
So, to make this leap from our sample to the whole population, we have to do it scientifically. We set up a kind of duel between two competing ideas. On one side, we have the null hypothesis. This is the boring default position. It says, nothing to see here, there's no real difference. And on the other side is the alternative hypothesis. That's our exciting new idea. It says, no, wait, I think there is a real difference here. So, our data showed a little difference in happiness between the groups. But here's the million-dollar question. Is that difference real, or is it just a random fluke from our specific sample? Just a result of that sampling error we were talking about? We need a formal test to see which hypothesis wins. And to do that, researchers follow a very clear four-step game plan. We've already got our two hypotheses. Next, we set our standard for what counts as evidence. Basically, how surprising does a result need to be? Then we run the numbers using a specific statistical test. And finally, we compare our result to that standard and make the final call. A really common tool for this is the chi-score test. And the way it works is actually pretty clever. It looks at the numbers we actually found in our survey, and it compares them to the numbers we'd expect to find if there was absolutely no relationship at all, if it were all just random chance. The bigger the gap between what we observed and what we expected, the more likely it is that something real is going on. And that test spits out the single most important number in this whole process, the p-value. The best way to think about the p-value is as a flukometer. It tells you the exact probability that you'd see a result as strong as yours just by pure random luck. A low p-value means it's probably not a fluke. So our p-value is 0.03. That means there's only a 3% chance that we'd see this difference in happiness just by random luck. And because that's so low, it's below the standard cutoff of 5%, we can confidently reject the null hypothesis. We get to declare our finding statistically significant. The difference we found is likely real. This is great news. We found a real, significant difference. But this amazing conclusion comes with the single most important warning in all of survey research. It's a phrase you've definitely heard before, and for good reason. This quote is everything. We found a correlation, a statistical link. We showed that coffee drinking and happiness are related in our data. But, and this is a giant but, we cannot say that coffee causes happiness. Maybe happier people are just more likely to choose coffee. Or maybe there's some other third thing we didn't even measure that causes both. A survey alone can't tell us why. So the next time you see a headline about some new survey finding, don't just stop at the conclusion. You're empowered now. You can ask the deeper questions. Was the measure they used reliable and valid? Is the result a real finding, or is it just a correlation? Knowing how to ask about the science behind the numbers is the best skill you can have in our crazy data-driven world.